Welcome to the panel portion of our virtual Deciphering AI event. Once again, I'm Lindsay O'Donnell Welch with Decipher, and I have two great panelists here with me today to discuss AI and the intersection of AI and cybersecurity. I have with me here today Gary McGraw, co-founder of the Berryville Institute of Machine Learning, and Nathan Hamiel, Senior Director of Research at Kudelski Security. Thank you both so much for joining me today.
Thank you
Great
for
to be
having
here.
us.
Yeah, so to start off, each of you discuss a little bit, just talk about what your AI story is. How did you get into AI and what specific aspects or pieces of AI and cybersecurity have really interested you in this area? Maybe starting with you, Gary.
Sure. So I wrote my first neural network in 1989, which was 35 years ago. And the LLM technology that we're all talking about these days is very closely aligned with what that was that came out when McClellan and Rumelhart wrote the PDP series of books about backpropagation. But then I stopped doing AI. I wrote my thesis on cognitive science thing with Doug Hofstetter. And then I stopped doing AI and helped to found the field of software security. Java came out, we broke it. We wondered why the people that built Java did it wrong. And it became clear to me that we had to build better software. So I worked on that for 25 years. And then after retiring from Cigital, I decided to see what's going on in AI in the last, say, 25 years. And the answer was not much. Computers got a lot faster, data sets got a lot bigger. The technology is pretty similar, although deep neural networks are deep. They have many more layers than before. And data sets are unbelievably large, on the order of, I don't know, tens of trillions of data points. Things we couldn't do with computers back in 1989, we can do now. But that's my background in AI. I've been working very steadily in machine learning security for the last 5 years. I have an institute called the Berryville Institute of Machine Learning, and all we do is machine learning security. And I guess that's about it.
Great. And Nathan?
Sure. So I have a non-academic approach to this, so for the past, 20, 25 years, I've been involved in cybersecurity, a lot in research and in software security. But really, where it kind of came about for me with machine learning was I've been in my current position 6 years. So it was before then I started noticing, like at Black Hat, every booth said machine learning. And I'm like, come on, everybody's doing machine learning. And then you'd ask people what they're doing and nobody would tell you. And I'm like, this, smells a little like snake oil. But I started playing around at that point, early on with, scikit-learn and doing some of my own experiments. And then later on, as I progressed through that, I started getting into experiments and things with PyTorch. So I'm a security researcher. I lead a fundamental and applied research team. So I do have academics that work for me. So we're both applied and academics, and we focus on emerging technologies. So before 6 years ago, I started getting into that. Mostly my background is in breaking things. I'm very interested in why things fail. So when it got to this point, around 5, 6 years ago, you started to notice that all of the recommendations around AI security all came from academia. And that kind of brings its own level of challenges. So some of the things I was reading were like on people were very concerned about adversarial examples in image-based systems. So there was recommendations. It's like, yes, just do adversarial retraining. But the reality of that is that nobody does that because in a lot of cases, you end up with situations where your model performance degrades rapidly. So sometimes on the order of like 30% degradation. So it really depends on the use case. And another fun one is I saw recommendations to use fully homomorphic encryption. So if you do not want to be invited to developer holiday parties, I highly suggest you tell them to use homomorphic encryption because they will hate you. So, those types of things are kind of what drew me in. And I started digging deeper and started building, my own experiments. So when I was hired as a senior director of research here at Kudelski Security, my job was to look 3 to 5 years in the future and set the company up for success. So a lot of what my team does is build new prototypes, build new experiments, things that are kind of applied to either our services operations or our CFC or even internal tools to help people do their jobs better. A lot of that does include some type of, machine learning, whether it be, traditional machine learning or something more like using LLMs, although that's been an interesting journey. So even before ChatGPT came out, I was very involved in NLP. So I built a few internal products, even one that we were going to deploy on our website, which was a scoping bot, which was a chat bot that helped us scope engagements and collecting information from customers. And I was told that people hate using chatbots, so we weren't going to deploy it. So I get to rub that in people's faces every day, which I enjoy doing. So that's pretty much how I came about it. And a lot of my team, so we focus on emerging technologies, so things like quantum security, advanced cryptography, privacy preserving technologies. Some of these, and AI security, of course, we built some of our AI security offerings at the company. And they're all kind of interconnected other than the quantum security aspect, because, there's a larger push for things like privacy and machine learning and things like that. So kind of all roads lead back to AI at this point, while we remain in this current hype cycle.
Yeah, you both have mentioned kind of how you've seen AI change over the past, two decades or more. And we all know that more recently, Nathan, as you mentioned, like AI has been like the big buzzword of the past, 6 to 12 months. Though this has obviously been around for far longer than that. How have you seen AI evolve over time, and where are we right now in kind of the timeline of AI? And by the way, I know I say AI, there's several different aspects to all this, whether that's LLMs or machine learning or otherwise. So maybe starting with you, Gary.
Sure. So AI started as a field in 1956 with some guys at Dartmouth who said they were going to build an intelligent machine in 2 weeks, which turned out to be a slight exaggeration. The first approaches to AI solved problems that we now think of as not AI, like search. If you ever heard of depth first and breadth first search from 1,000,000,000,000,000 years ago, which we use every day, or bubble sort and all that stuff, that was all AI research 1,000,000 years ago. Generally speaking, in the field, if something gets solved, it's no longer AI. Now that's changed with all the hype around machine learning, which really came into its own. I'd say 1989. There was early work in perceptrons before that, but it was slowed down by Minsky and Papert for 30 years, and then it sort of burst back into the vogue in '89 with connectionism and neural network stuff. But it never really hit the mainstream until about, I don't know, 10 years ago. And 5 years ago, there were some pretty major breakthroughs in larger models and huger data sets. It's important to understand, like Nathan said, that there are a whole bunch of things that are called machine learning and AI. And what people are mostly concerned with today are these large language models, which are a kind of deep neural network technology. So that's a small subset of machine learning, and machine learning is a small subset of AI. But that doesn't really matter. I mean, what we're here to talk about today is what's going on at the edge of LLM stuff and what we can do to secure that, or if we can even secure that. And this is something I've been working on for pretty much my entire adult life. And I think that we have a long way to go to think about security. It reminds me of helping to invent software security in 1999, when everybody was building firewalls and talking about network security, and nobody stated the obvious, like, why is the software broken? We want to put a thing between the broken stuff and the bad people. How do we do that? And it took 20 years for security engineering to really boot up properly and become commercially relevant. And many of the things that we built properly, people carry around in their pockets today, like those credit card chips. And we built those properly from a software security perspective. Same goes with most of the software built in financial services these days. We need to have the same sort of approach to technology behind machine learning and large language models if we want these models to be useful and not just parlor tricks, which is what I believe they pretty much are right now.
Yeah, that's a good point about kind of the approach that we need to have. Maybe we could take a step back and look at, like, we've seen a lot of discussion, as you say, Gary, about the challenges with AI and cybersecurity. And, what strikes me is that there's two kind of disparate categories here. There's the models themselves and the risks there, and then the potential use cases that have been discussed in the cybersecurity landscape. Um, when it comes to AI and cybersecurity, what do you feel are some of the most significant challenges that are important for the cybersecurity industry to take note of, with the models or the use cases? Nathan, what do you think there?
Sure. I think it's all about the use cases for the most part. So when I take a step back and look at this, there's a fundamental thing that isn't being kind of addressed, and that is that deep generative AI integration into everything is bad for both security and privacy. And right now we have right now we have a almost a reckless scenario of trying to shove generative AI into everything, regardless of whether it solves the problem or not. So if you look at what Microsoft is doing, they're trying to push generative AI deep into the operating system for what I can only assume is so that people can generate memes from the command line. So I think we're not doing a good enough kind of thought process around what the trade-offs are versus what we're getting. Another example of this is recently Mozilla laid off a bunch of people and started to decommission projects, privacy projects, so that they could focus on bringing AI into Firefox, which is something that absolutely no Firefox user asked for. So there's this fundamental disconnect between what people actually want and what we're getting. So it seems like we're getting generative AI whether we want it or not. And there are critical aspects to things like large language models. These are experimental technologies that are now going into production. And every single day they are failing across the board. And we seem to be okay with this. It's like, well, maybe we didn't push hard enough, or maybe we didn't make our prompts good enough.
Nathan, they're doing exactly what we designed them to do, which is not the right thing.
Yeah, correct. And I think that there's way. I mean, if you consider the use case, right? Like if you're building a video game and your chatbot gives you bad advice and you go to the wrong location, it's not the end of the world. So I think we need to kind of have this look at the use cases, because it used to be we had machine learning approaches, we had deep learning approaches, and people would think more about their performance. So we had ways to benchmark those. We had scoring mechanisms which we could apply to them, and people were concerned that their model wouldn't generalize when they pushed it into production. But since we don't have great benchmarks for things like large language models, people are at will pushing them into production, and when they fail, they acted like it was something that was completely unexpected.
Can I throw a little bit of optimism in? I totally agree with everything that you said, but my belief is that the technology itself is not as broken as the data sets that we're using to train up large language models. So, the scrape that OpenAI used was 14 trillion IO pairs with a 1.7 trillion parameter model. That's just immense. It cost about $56 million to train that thing up. And it has a lot of garbage and pollution and noise and just wrong stuff in it because the internet scrape is full of that. Now, the real question is, can we build an LLM that's large enough with a better data set that doesn't include all of that hainosity in it? But as you said, we're in a big rush to just apply the current generation of LLM stuff, regardless of whether it fits. We're often putting a square peg in a round hole, exactly the way you described. However, I think I'm pretty excited about the technology and, frankly, absolutely surprised by the power that we get out of these statistical models. I did not think that auto-associative predictive generation would go as far as it's gone. Now, part of that's the ELIZA effect. That's people just believing the thing understands, even though it's just a bag of words predicting the next bag of words. But it turns out that with just bag of words prediction and better bags of words to train with, better data oceans, maybe we can have a technology that does some incredibly cool stuff and breaks through in ways that continue to surprise us.
Yeah, I mean, you guys are making some really good points here about like everything from like the issues with data, like whether it's the curse of data or like data feudalism, as you know, Gary, I know you've talked about, but the models themselves, and then all the way to like use cases and really just like the purpose behind kind of AI. You know, when we look at some of these challenges, what would you say, where do we need to start to even think about addressing some of them? And maybe we should start by looking at like the models themselves, because I know that there's a lot of risks there that pop up that are kind of out of the hands of, you know, end users or businesses, or, you know, how they're being used in applications.
I can take that real quick. The thing that we got to remember is why we want to use machine learning. If you know how to do a problem, if you know how to solve a problem, you can write a computer program to do that, especially if you know how very specifically. If you don't know how to solve a problem, you often take a pile of what and you train the machine to, in some sense, become the what. That's machine learning. And then you have a what machine. So if you take a billion data points, which are statistical predictions, and you build a what machine out of that, you're going to get whatever's in that data. That's what the machine becomes, so to speak. Don't forget when you're thinking about an application that if you already know how to do something, perhaps you should just write a good program to do that, not throw ML at it because it's the latest shiny thing. There are some things we don't know how to do. When we build a what machine using machine learning to create that technology, we still don't know how those things work because they're so huge and the representation is so inscrutable to human capabilities that we just sort of count on the thing to do the right stuff. And when it doesn't do the right stuff, that can lead to very serious problems. As Nathan pointed out, large language models today at the edge, they are stochastic models that sometimes are unbelievably wrong. So if you count on them to do something like, say, drive your car, and they end up crashing because they make a mistake and kill somebody, that's bad. Don't use a stochastic machine to drive your car is the answer to that. Do a different kind of engineering. So I think that what we have to do is be very cognizant of when we use machine learning. We shouldn't throw out the baby with the bathwater, but we should not be using machine learning just because it's the shiny new thing. If we can think of other ways to solve the problem that are often safer, more reliable, and ultimately something that we can understand instead of just throwing machine learning at it.
Yeah, and to take that a step further, so what Gary described is exactly the alter opposite of what's actually happening. So we tend to think of using machine learning as a component inside of an application to give us a prediction or something. So it's one small component. If you remember the technical debt machine learning paper from Google from 2015, I think it was, there was like this little black box in the center of the architecture, and then there was all these other components around it.
Right.
That now looks like a gigantic black box with several components around it. So not only are developers using LLMs to get some sort of result, they're actually replacing functions in their applications with large calls to LLMs. So they're collapsing the module where they normally have a modular architecture in an application. They're actually collapsing it down into like a big prompt and then getting a result. So the visibility problem, like when something fails, how do you know where it is? And then of course it's going to cascade through your application. So I wrote about this last year in an article that nobody reads called The Brave New World of Degraded Performance. And I was saying that you'll get all these applications that still kind of do what they're supposed to do, but they won't be as good as the old version because they'll be less reliable. You know, failures will be harder to troubleshoot. And just this week, another example of this cropped up. My friend Yolan was talking about using Notion. And he's like, why can't I just simply search for this in Notion? I have to use this Notion AI workaround and write a prompt to get something I should simply be able to ask a question for. That is a good question to ask. Like, why was that not thought of? So by deploying this stuff and trying to address highly complex problems with machine learning, and make it simpler, we may actually inadvertently be making simple problems much harder or more complex.
Well, another good example along those lines is search. I don't know. Google used to be great. Now it sucks. The reason that it sucks is because they actually do query an AI engine and they bring back some sort of a pablum version and put it in front of you, often missing links because the original websites are no longer cited. Now, the reason for that is because in an attention economy, you want to hoard attention. So you get somebody to use your search engine. You don't ever want them to leave search engine land. You want to keep their eyeballs. And so if you use an LLM, which may be wrong or may have, worse answer capability, but people don't know that it's wrong and they just don't want to click on a link and go look at a whole nother website, then you have the current situation. So I sort of believe what you're saying about, cognitive, what did you call it, degradation?
Yeah.
I think I think there's some truth there. And we have to think about those things and the incentives that we've set up in the surveillance capitalist economy to make that happen. You mentioned data feudalism before. I want to get to that too. Assuming that we can't scrape the internet anymore because it's not big enough. That's one problem. There's another problem, and that is that the data ocean is being divided up by people who have interesting data piles. For example, Google search history or X/Twitter history of tweets from all time, or Meta's information on all of their users and interactions. Those data are no longer being shared willy-nilly with everybody like they used to be, because it turns out that they're not just valuable for micro-targeting advertising and politics. They're actually also valuable for training machine learning models. This means that those people who already have massive data sets can kind of hoard them like kings used to hoard land back in the feudal days. And so that's what I think is a real problem we need to address now. Now, what are we going to do about all this? Well, I don't think we can stop people from using this stuff. So we just have to just say, be Cassandras about it and say, guys, we got to be careful about this. And those people who apply LLM technology carefully with forethought and think about security engineering while they do it are going to be those who survive. And the people who build just junk are probably going to go by the wayside. So don't be the ones that go by the wayside is the answer from a business perspective.
You guys raise great points. There have been a number of government initiatives around AI, such as the White House executive order, but also a lot of this has been voluntary at this point. And so I want to get your thoughts on what the government is doing right so far and how it's looking at AI and really where that fits into cybersecurity. And what do we still need to do to address some of these risks with AI? And also, if we're targeting kind of the right types of companies or people or, the ones who are kind of making different moves throughout how AI is being developed or used at the end. So, Nathan, maybe if you want to go first there.
Sure. So I think one of the things that the government is currently doing right is that they're moving faster than they normally move. So it's nice to see that. I mean, of course, technology is far outpacing government regulation. I don't think that'll ever change. But one of the things they're trying to do is be a lot more proactive around these things. So I think that's being positive. I don't know how much I would brag about that, but it's very good that they're doing that. So I appreciate the speed. As you mentioned, the executive order is an executive order. It kind of doesn't force companies to do the right things, but I think it kind of focused on a couple of good things. So there was an emphasis on cybersecurity, if I'm remembering it properly, because I haven't read it recently, but I remember it having some impacts on cybersecurity and looking to use tools to increase cybersecurity, things like code security, things like that. I'm hopeful in that area. But there was also some downsides. Like there were some things in there that probably shouldn't have been in there. I think it mentioned a number of hyperparameters before something kicked in, and there was the use of the War Powers Act potentially to kind of force companies to do things, all things that haven't come to fruition. But I think that's kind of focusing on some of the wrong things. It also seemed like an opportunity for regulatory capture from some of these larger organizations, which wouldn't be good. So I think there's still a long way to go. They need the right people in place making the right recommendations. However, on the flip side, some other things that they're doing well is empowering NIST to kind of focus on some of these things and put out some standards. So even though they're not mandatory, people have something they can start with. I think that's great. And if you think about the FTC, some of the things they're doing are they're being a lot more agile. So things like warning companies to be truthful in their marketing documents. We'll see how that plays out too. And of course, recently talking about the emphasis on, deep fake audio in phone conversations, trying to scam people. They've been pretty proactive about that. And something else that hardly ever gets talked about is the environmental impacts of things like generative AI. So when coal-powered power plants stay online for proof of work cryptocurrencies, everyone loses their minds. But when they do it for generative AI, you're getting cat memes instead of bored apes, and that's okay. So recently, there was a piece of regulation proposed called the Artificial Artificial Intelligence Environmental Impacts Act of 2024, which kind of tasks to Honda creates a task force to kind of study these effects and to find out, because it's a closely held secret about just how much energy consumption is being used, water consumption is being used, to not only train but to also run this on a daily basis. So I think there's some things that are doing right and some things that really need to be improved. The one thing that concerns me across the board is kind of the attack on open source models. I think that that is a place that allows large companies to get some regulatory capture and try to push startups and smaller organizations out of the conversation. So I think the dangers that have been talked about with open source models are wildly overblown. And I think that a lot of the talk about how open source models are dangerous is pure nonsense.
Gary, what are your thoughts?
Well, let's look at the landscape. So the United States executive order we've talked about a little bit. Before that, the European Union has been very active in AI regulation. In December 23, they announced the EU AI Act, which they're planning on turning on any one of these days. They're not going to really go into effect until 2026, but the regulatory framework is already making a big impact, even on US regulation. Now, I think that what Nathan said last is very important. The big companies should not be allowed to bully startups or open source models through regulation. And part of the answer is that what needs to be regulated are foundation models, not the use of AI, but the creation of AI foundation models. So I would like to see, for example, people who create an LLM foundation model that's not open source have to disclose which data they use, where they got it, what they did to clean it up, things like that. If you want to look into the specifics, we actually published on January 24th, 2024, a report called An Architecture Risk Analysis of Large Language Models, Applied Machine Learning Security from Berryville Institute of Machine Learning. And in that, we talk about the architecture of LLMs. We talk about black box foundation models, all the stuff we've alluded to today. But we identify 23 risks that should be targets for regulation to control large companies that are building foundation models that everybody's using, so that we make sure that we don't build things that create even more recursive pollution than what we've already experienced so far. And we think that that's really the way to go. Now, those of you who've known me for 30 years, like Dennis, for example, will say McGraw says we should regulate stuff. Holy cow! Because that's not my usual position. I'm a hardcore capitalist for sure, and it is my position in this case because I think that the large multinationals are, in some sense, putting the cart before the horse when it comes to large language models. And putting stuff that is still kind of at the edge of science that we don't understand into applications too early. The way to control that is to control that technology in a reasonable fashion, not kill it, not outlaw it, but think about how to do it responsibly and open up the black box, turn on the lights, and check out what's in there.
Yeah, one thing I forgot to mention on this was I am much more concerned about the use of AI. I understand that if you don't have a good foundation, then anything you build on top of it's going to be. So I certainly understand the approach to going after the foundation model. I am much more concerned in the near term about people using what we have today in specific use cases. And I wish that there would be regulation around specific use cases. So in the video game industry, you know,
Who
go
cares?
wild. Yeah,
Right.
but if you're building a psychology chatbot that's supposed to be to help people with mental health, like that should be clearly regulated, tested, and there should be a different number of requirements around that versus the gaming industry. If there's finance stuff, like there's been some really funny to me because it hasn't happened to me, but people using like auto GPT to do stock market trading or do something with cryptocurrency and it drains their cryptocurrency wallets. So we can all have a laugh at that. But I mean, those specific use cases around finance, around healthcare need to be controlled and regulated.
I agree with that, Nathan, but I do think that we should regulate the creation of foundation models first, not ignore the other, but first things first. I do want to say this. You said psychology, which is hilarious because one of the first AI programs ever written was written the year I was born, 1966. I'm 58. I'll be 58 next week, actually. And that was written by a guy named Feigenbaum. It was called Eliza. Eliza was a therapist, and you would type in some questions and have a conversation with Eliza, a very early bot, which just used simple keyword matching to ask you questions about telling more, trying to elicit conversation out of you. People believed that Eliza was a real conscious thinking entity in 1966. Now you can imagine with the progress we've made since then, 57 years later, in AI and LLM technology is actually marvelously interesting. What the Eliza effect is like today, and what Nathan said, that cautionary view, let's don't use this for psychology, is ironically just as right today as it was in 1966.
Mm. Yeah, yeah, that's it's a very good point. Well, from 1966 to now, how do you see what do you see coming over the horizon really as it relates to AI and cybersecurity that we should be looking at, and how do you see this space continue to evolve? Just before we wrap up here.
So I'm going to take this first. There are a lot of startups, including apparently Nathan's, in machine learning security. There are some things we need to do that are pretty obvious. Number one, we need to identify where machine learning is being used. That's hard. A lot of CISOs think that they have banned the use of LLMs, which is absolutely hilarious because everybody everywhere is using them for all the things without the CISO knowing about it. So find it is number one. Number two, threat model it. If you think you have machine learning application in a box, surrounded by other stuff, the way we've been describing in two or three different ways, what are the implications to the system of using something like an LLM in your design? Irius Risk has a good threat modeling tool that has built-in stuff just for that. Number three, start to control the risks that are identified by threat modeling. Control them with technology that does things like monitoring LLMs, looking for PII leakage, all sorts of other things that we can do. I'm associated with a firm called Calypso AI that does that sort of stuff. In my mind, those are the three top things we should be doing now. Should we be using LLM technology to do cybersecurity? Well, it turns out that there are some firms that have been doing a very good job with that behind the scenes for many years. One of them is Redshift, so you can check out how they're using very constrained LLMs that are built with these strict controls to do some aspects of cybersecurity. But the key to that is, putting controls around the technology so that it can't do bad things. Just like Nathan said, you can't just willy-nilly throw an LLM into something and expect magic to occur. It's not the magic module. But it is an incredibly powerful technology. I am optimistic about it, but I'm always an optimist. I've been in security since 1995, and I still think we're making progress. So I must be one of the crazy people. But I got to tell you this, having used natural language processing stuff for years, even pre OpenAI's breakthroughs, um, I feel kind of about LLM technology today as excited as I felt when I got my Apple II Plus with 48K in 1981. It's really just like wow time, and it's fun to play with this stuff. So I want to sort of end my own thoughts on this with a note of optimism, thinking that we can make great progress with some of this stuff if we do it right. So let's do it right.
Yeah, Nathan, anything to add there?
Yeah, sure. So there's two different aspects here. There's the building solutions based on things like LLMs, and then there's people using LLMs to solve problems. So I think we should always be trying to solve problems and not applying technology solutions. I think you absolutely have to start from the use case. I'll sound like a broken record on this. If you don't understand the use case you are applying the technology to first, even before threat modeling, you can have a lot of very big problems. So for example, what is the cost of failure of a use case? So, I mean, are people going to die? Is there going to be a negative financial impact? All of these things. Not every system is going to have a high cost of failure, but you still need to understand that. So last year, at one of the heights of this craze, I needed a way to discuss this and discuss, going through the risks with developers, and also giving them some tools to help protect. So I came up with a method I call RRT, which is refrain, restrict, and trap. And so you start thinking about these different components, and can you refrain from use? Is there a better solution to that? Can you restrict? Can you add appropriate permissions to stop things from going out of control? And then can you do trapping on the input and the output to help solve problems? So none of these are fixes for the very real and deep problems inside of LLMs, but you can reduce your risk to an acceptable level. So kind of on a scale of terrible to perfect, where do you fall in there and what is acceptable? Because obviously we don't live in a perfect world. So I think that's first and foremost. I'm a little more of a pessimist on what LLMs can actually do. I mean, a lot of people talk about them moving towards AGI. I think that is not going to happen. I think that, we're fooling ourselves if that's the case. Doesn't mean they're useless, but the real absolute risk from large language models isn't LLMs becoming AGI and destroying humanity or taking everyone's jobs or whatever. It's using LLMs as though they were AGI to solve problems without acknowledging all of the issues that are ingrained in there. So my non-pessimistic final thought, I guess, would be on, I am more bullish on use cases around code, because I think we have lots of examples of code, and I think there are some ways to enhance code security through using tools like large language models and working it into development environments. Still need humans in the loop, but I think we're getting to a point where that could be possible. There are lots of really cool companies working on this as well. So I think we could find some things there. There's also been some interesting research behind the scenes. Some people have seen some conversations around areas of finding vulnerabilities with code or with LLMs and things like that. So I'm a little optimistic there on that front. But as far as like a robot powered by ChatGPT, I think that will terrify me for years.
Yep. Well, on that note, Gary and Nathan, as we wrap up here, I wanted to thank you so much for your time, and you both have very great, well-informed, insights into AI and cybersecurity. So I really appreciate you coming on and talking a bit about what you're seeing.
Pleasure to be here.
Yeah, great. And thank you everyone who tuned in today for our virtual Deciphering AI event to hear all about AI and its intersection with cybersecurity. Thank you.